Subscribe for more space.
Well, hello everybody. This is Scott Roberts, and I'm joined here by Tyler Bowman and Jerry Hubbell. Yesterday, Jerry was feeling a little under the weather, and so we switched schedules. But he's back today, and so
Yep, I'm
good
back.
as new. Good as new.
hmm I wish.
Yeah.
No call.
Yep. So I know we've all been busy. You were in a couple of meetings with us today earlier. Um,
Yeah.
Tyler, I saw you out in the studio, not the studio, the showroom filming something today. What are you guys working on right now?
Oh, we were doing something for our sports optics brains.
Okay.
We had a Zoom meeting of about 50 people in there, and they said it was the best production ever. And I'm just sitting here moving the camera.
Woohoo!
That's about it.
Yeah, so we not only do these shows, but we do shows for, for our resellers, our dealers, it's in this era of the pandemic. It's actually worked out pretty good. No one has to fly to some place to have this massive meeting, and
Right.
so I think that a lot of companies probably have seen some savings there, but the big challenge is how do people touch and feel the product, so that becomes an issue. When I would go and do sales programs as well, I mean it was just kind of nice to do, where you'd set up everything into their breakout rooms, and and let them actually check and see what the quality of your product was like, So,
Right.
one of the things we pride ourselves on, even in our toy line of products, our toy telescopes, our toy microscopes, are the optics themselves. That's where we separate, from our competition, and uh, you know, uh, we let them know that we understand what a good optic is like. So, we hope that all those people that buy a beginner telescope actually have a good optical experience and move on to something that might be a little bit more serious, to meet people like you that are watching this
Hmm.
show, because I know that all of you out there love astronomy. You love, getting the right gear to observe the stars with and everything. And but that takes a learning curve. It takes time and it takes money. Okay, so those are some of the things that a young
Right.
young person doesn't have. A
But
lot.
but there's a lot of even for young people. It's about the journey, not just the equipment, right? So it's really a learning experience, and
That's
people
true.
that
That's true.
that want to get into continuous. I always tell people that a lot of people say this is that you need to learn over your whole lifetime, not just in school and think that it's a pain in the butt and get out of school and now I don't have to learn anymore. That's the worst thing to think is you don't have to learn anymore after you get out of school because there's
There's a lot of
value.
people
There's
that
a Yeah,
they're done with school and learning and researching something. They just they kind of stop. And but I do notice that there are more lifelong learners. There are in colleges and universities. There's lifelong learning programs and stuff like that. So you'll see people who do finally retire or whatever, and they'll go back to the university and try to get
right,
a degree.
right. It's no, there's right. It's always an opportunity to go back if you want to get a formal education anytime during your life to do whatever you're interested in. Just do it.
That's right. That's right. But what we do on this show here is try to give an education on various topics, including not only our gear, but how to do different aspects of astronomy. And I love it when we have our global star parties, which, by the way, we're having one tonight. It'll be our 30th global star party. But I encourage people with any kind of gear, any brand, any type, to get on the show, to show how they do it, how to share their experiences, and all the rest of it, because that's what keeps us all engaged. So but uh, we are before I get to Jerry, Jerry's going to go over one of his programs that he's done for astronomy clubs. Tyler, how is customer service? How are things going? It seems like we have finally started to get caught up. We were admittedly behind in calls and emails and chats and stuff after the holiday rush, but and checking on things today, it looked pretty good.
Yes, making sure that we are caught up. This last week we've done nothing. We finished up playing catch up. So we're right where we need to be. Answering the emails like we're supposed to, doing phone calls, taking care of our customers.
Hmm.
And of course we have Jerry and Scott to help us with that. Of course,
Right. I
doing
do want to give a shout out for Tyler. Tyler is relatively new to our company, but he's
was it
already made it
7 months?
to manager of customer service. So he's someone that's very, dedicated to the hobby, dedicated to the lifestyle, has really dug in to help customers, and has, in the best tradition of helping out customers, you don't see Tyler leaving exactly on 5 o'clock on the dot, or
Right.
he's here early. He stays late. He's here on weekends, and he takes the job home with him, often. So but that's part of it.
That's part of this lifelong learning thing and what you can do to improve your career in general, right? So I took this tack when in my career in nuclear engineering. I just if I had a problem that I could figure out an answer to and I thought about it at home, I'd work on it at home and then bring it back to the company.
Yep.
You know, you just it helps you, it helps yourself also. It's not just helping the company. It's building your career and making yourself
Brain
valuable.
cells going, right? I mean,
Well, it makes yourself valuable to the company. That's what the goal is. You want to be as valuable as you can be to the company.
right. Yeah. Well, Explore Scientific is a growing company, and we are, we're excited for this year and the next. We got a lot of new products in the works, and so in the future you're going to see a lot from Explore Scientific. But I think also that we're going to see, with our mentor training and the whole mentor program,
Yeah.
you're going to see that flesh out more and more through almost everything that we do. So I think it's very important.
Scott, I do have a question before we get to Jerry. So I'm seeing on your desk, there's a gold placard on looks like an ED 102. Who's that from?
Oh yeah, that's
Oh, you
kind of
mean this telescope right here?
that's kind of interesting.
Where can I get a gold placard?
You can't. You can't. This telescope actually belongs to Buzz Aldrin. Okay, and you'll see that there's a special placard here. It says Buzz Aldrin Moon Explorer, and in this gold placard, let's see if I can reach it. Right here, you can see it's kind of dark here. The reason why it's dark is that is actual lunar meteorite material actually embedded in there. And so, he has an Explore Scientific ED-102, and we're refurbishing it for him, and cleaning and collimating it and all the rest of it. And but he's taking good care of his scope, so it's been nice.
How long has he had that?
Oh, goodness.
Been over 10 years.
Not over 10 years, but probably like 7 or 8 years, something like that. Something along those lines. So
That's neat.
yeah, when I think of a guy like that owning a telescope, I think of, there's a lot of people of science have owned a telescope. Although Einstein was not an astronomer, he owned a telescope. He had a beautiful brass telescope. I think it's still on display at the Chabot Space and Science Center. Having a telescope or a microscope or whatever, if you were someone involved in science, those are just instruments that you owned, to explore the sky around you or to explore your world around you, so.
Right.
So I think it's cool, but it's obviously an honor to take care of Dr. Aldrin's telescope. So, so let's. I don't know if you have anything else you'd like to add, Tyler, but
Who's on the broadcast today?
You mean for the Global Star Party?
No, well, you can talk about that, but also who's listening to us right now?
Our audience.
We gotta have to acknowledge our audience every day, right?
Yes, we do. That's right. Of course, we have Richard Grace. He was the first to respond here, and then we have Mike Wiesner. Mike says, "Hi from snow-covered southern Arizona, 2 inches from yesterday's storm." Wow. James, the astrophotographer, is on. James Hubbard. Richard Gray says we got an inch here, but it's gone already. I think we got about an inch as well.
Give or take. I think James has been clouded out for almost a month.
Yeah. We've been clouded out for a while here too. Josh Bush is with us. He says, "Why is it that when you get a new telescope and you're ready to try it out, it's always cloudy for the next week?" It's a rule.
That's a rule. That's right.
Astro gear, you start seeing it really cloudy all the time. It means a lot of people around you have gotten new telescopes or eyepieces or a new camera or something like that. So
it's karma.
It's karma. Exactly. That's exactly what it is. Michael Whitaker says, good evening, everyone. And Book Davy says he got snow and overcast in Kansas, too. Streets are clear, but the ground is covered in 2 inches. Michael Whitaker says hello. And who else? Eric Cole. He says volume is good. Thank you. Book Davy says not lowish. That's good. I had problems with my volume yesterday. I don't know what it was. It was bizarre.
Oh, really?
Yeah. We have Clear Light 58 on with us. And who else? Christy White. Way to go, Tyler. Mike Wiesner says, excellent, Tyler. So, anyways, later we're going to give out Tyler's home phone number and his home mailing address.
Go for it.
You're gonna dox him.
Go for it. I don't have a home phone number.
You don't have one, do you?
Go for it. I'll pick one out in the phone
We
book.
installed one. We installed one in your home.
Oh, did we?
I'm kidding. Let's see. Gary D. Burrell. Hey guys, I ordered a First Light 127 Mac to go with the Nano mount 10 days ago in the observatory tent yesterday. Any estimate on when you will receive these to ship out? Okay, well, I know that the tent is not quite here yet, but I'm expecting about 2 to 3 weeks. The 127 Mac, that would have to be something we would check on.
Actually, I've seen one.
You seen one? You see his order?
Probably not his order. I was going to ask him if he could email me.
Yeah. Why don't you do that? Send it to tyler@explorescientific.com, and Tyler will check it out for you.
Mm-hmm. I got to get duty calls. I got to go with everybody.
Thanks, Tyler. Take care.
See y'all.
Yeah.
Bye.
Hugo Brunet says hi from the Fulham Optique team. Yeah. Really brilliant and talented astronomer,
nice.
Hugo. Brian Fanning says hello from New Jersey. It's raining. Richard Gray says he got new rings and dovetail today. It looks cloudy outside, of course.
Yeah, it's been raining and cloudy here
Yeah, right.
today.
And Book Davy says, and Zach were Australian. Oh, okay. They're having a private conversation here. Josh Bush. I was like, and Zach? I don't know. Yeah. Josh Bush, just up the road from you, Scott. So you know what I'm talking about in this Arkansas weather. That's right. Jim Norwood says, I'm late to the party today. Not sure if I'm seeing it delayed or real time at the moment. You're seeing, Jim, you're watching it in real time right now. So welcome to our live show.
I've noticed that on YouTube. You can watch a live program. If you miss part of it, you can scrub back to the beginning and watch it as it's being broadcast also
really?
from the beginning.
I
Yeah,
haven't even tried that.
that's pretty cool. Yeah.
Yeah. Well, and let's see who else. I think that's it. Oh, Matt adds hello from North Carolina. So that's who's chatting with us right now. We know there's other people watching the show back there in the background somewhere. I do want to talk about the Global Star Party tonight. It's our 30th, not 30th anniversary, our 30th.
Yeah.
Our 30th Global Star Party. We've done them weekly, pretty much every week, except for we took a little break during between the Great Conjunction and about the first week of January.
Mm-hmm. What show is this?
This show right here, this is
It's
number
115? Oh, 120.
3 or something like that.
Really?
Yep. So
that's a lot of shows.
we've done a lot of shows. And we've done a lot of different shows, so we've had our beginner show with First Light Chronicles. That's getting upwards of about climbing up to 20 shows right there. There's a lot of TV series that don't make it this many shows.
Yeah, we try to be different every day too. It's hard to, not cover the same thing every month,
Yeah.
you know.
But sometimes you have to. You
Right.
know.
Well, we got new people coming on. You want to be able to still
That's
share.
right. You don't want to leave them in the dust, you know.
Right.
So sometimes we do, and
But we'd like them to go back and watch all our shows, like one of our viewers did.
Oh my
Who was it last week that said he watched all the
He's
shows?
been watching our shows, so I can't
Yeah.
remember.
Like we got 60
He's
hours of
probably watching
shows.
right now. So
Well, we probably got 100 hours of shows
I would believe
at
so.
least.
Yeah. April Lewis it says hello from Ohio. It's raining, sleeting, raining, cloudy, etc. Well, so this is what we do when it's cloudy and raining outside. We have a global star party, so somewhere on the planet maybe we'll have some clear
If we're lucky.
skies.
We've
That's
run
right.
into that where we've had ones where nobody had anything, right? Didn't we have
That's
that one
true.
time?
One time.
Yeah,
one
that's
time. I think so. Or maybe it was like only one place was clear, something like that.
yeah.
But it's amazing how cloudy the whole planet can get. So, not that we have astronomers set up everywhere, but you would think, okay, if it's in South America or in Europe or, you know,
In Asia.
Canada or someplace like
Yeah.
that, you'd think somebody would have some clear skies somewhere. And how's your skies out there, Jerry?
We're overcast. It was actually snowing the other day, also a little bit, not much, but it's rained today, and yesterday it was raining.
Well, we do door prizes for Global Star Party every time we do it. But this time we'll be giving away some 30 millimeter eyepieces because it's the 30th.
That's a special. That's a special prize. Yeah.
Yeah, so I'm excited about it. When we get to our 50th Global Star Party, I don't know what we're gonna give away. So,
well, on our 100th episode of the OpenGOTO, we gave away a 100-degree eyepiece, didn't we?
We sure did. That's right. So, we just try to keep it fun. But for Global Star Party tonight, we have Molly Wakeling will be giving. Normally she's doing astrophotography, but she's clouded out. Okay, so Molly said that she would be giving a presentation. We've got Kelsey Poor from Nova Space Gallery. She's going to be on with a space artist, Dan. I'm forgetting the last name right now. I'm embarrassed. Dan Durda is his name. And Dan he starts off as I guess a professional astronomer turned artist, okay, turned space explorer, okay. So he's apparently working with NASA and maybe flying in low Earth orbit. So
that's cool.
You look him up on Google Images and stuff, and you'll see him on zero gravity flights and stuff like that. So it's pretty cool. And so I'm very excited to have him on. You know, it makes me wonder what makes, you know, how an astronomer or somebody makes this connection back to art and trying to express themselves. You know, so
right.
Because a lot of people that are kind of, you know, higher up in the echelon of astronomy are scientists and they're engineers and stuff, and a lot of them don't have that side to them where they can express themselves artistically, you know, but some of them do. And so Dan is one of these people, and if you look at his paintings and stuff on, if you do Dan Durda space art, you're going to see some really cool stuff, and we'll see it tonight.
I've attempted to do that a little bit. I've got one drawing. I've got one digital drawing I did based on a photograph of the moon that I did, and
Yeah.
I don't know if I want to show it or not. It's
How'd it
kind of
come out?
cool. It's kind of cool. It's kind of a little bit abstract, but it's maybe I'll show it if I can find it.
Yeah, we'll have to see it. So, when I was a kid, I think I talked about this before, but I used to make plaster of Paris motifs, okay, of the lunar terrain. And so I would make
that's cool.
craters and stuff into plaster of Paris. I'd paint it gray. I'd put the you know, the markings, or, you know, the blast marks of the. But before it all, you know, as it was drying and stuff. Now this is back in the '60s, and back in the '60s, what did we have in our televisions back then? We had tubes, not transistors and stuff.
Right, tubes.
So
right, exactly.
my dad used to let me keep the old tubes, and what I would do is I would put the tubes into the plaster of Paris, so they look like these miniature high-tech cities. Okay,
Oh yeah, that's cool.
so
That's neat.
I was crazy about space exploration back then, and I envisioned that at one point I would actually be able to build my own rocket because I was into the model rocketry team, and that I would be able to fire a mouse or something into space. And so I made like I drew a liquid cooled spacesuit for a mouse, and
I was I
made
found
it. I never actually tried to do that, but
I
you know,
found my
it was
yearbook.
cool.
I found my yearbook from when I was in junior high, or in actually middle school and seventh grade at the rocketry club. You never see such a bunch of little geeky kids. I'll have to dig that out too and show
Yeah.
what the rocketry club looked like in 1974.
So I had an Estes rocket that I built. We have a really big one in our
Oh
showroom.
yeah,
It's like, you know, 20 times the original size of the original Estes, which is only about, maybe a foot
foot,
tall.
right?
Okay. And when that thing fired off, the force of it just blew the fins off, and melted the parachute and stuff. So.
Right.
But after watching, the real guys do it and blowing up big ones on the pad, I guess I really can't be too hard on myself. So, but one day we think that we will actually have a contest of some sort because we have large and dangerous size rockets in our showroom. Two of them. We have a V2 replica, and we've
Oh.
got a
Hmm.
the giant Estes in there, and they take a rocket engine that's roughly, I don't know, 5 inches in diameter,
Yeah.
about that long. They fly pretty high, but we have to do that out in the desert. So
Right. The high power rocketry. There's a lot of good videos on
yeah,
YouTube for high power rocketry.
so there are clubs that you can get with, and they would. We've talked to them in the past. And they said, "Yeah, bring your rockets out. We'll put the electronics and the GPS and the cameras and all the rest of the stuff in it." But it's when we do that, we'll have to do a live broadcast of some sort if we can. So that would be
That's another area of amateur science that's really taking advantage of technology. It's pretty amazing.
right, right. If you watch some of those Google videos, there's guys flying amateur rockets to the edge of space. It's pretty,
Yeah. The
pretty.
other thing is the high altitude balloons. Those are kind of cool to watch
It's
too.
very cool. We flew an Explore Scientific ED-80 carbon fiber to the edge of space, and they did video of it. I'll also have to see if I can dig that out again. Um,
Yeah, that's cool.
yeah, so it's just some of the geeky stuff we've done at Explore Scientific. So, but it's fun. It is a lot of fun. Um, Jim Norwood says you have to get special permission from the FAA to fly the big rockets, right? Yes, you do. Yeah, you have to have permission, and they only let you do it in certain areas of the country. I think maybe out towards Nevada, maybe towards Black Rock or something like that. They do it.
Hmm.
Um, but yeah, we'll have to. Our idea is that we would have a science project or something to encourage kids to get involved in science, and the winner of that contest, first place and second place would get a chance to fire off those rockets. It'll be fun. Yeah. Mike Wiesner says, Mike's done everything. I did a
Yeah.
model rocketry program at our local grade school a couple of years ago using Estes
Oh,
rockets.
nice.
Yeah, it would be cool to interview someone from Estes that's been there a long time, just to hear all the stories, the rocketry stories.
Right.
But let's turn this over to you,
Okay.
Jerry. And I know that you have given talks to all kinds of astronomy clubs, and this is
Yeah.
for the Rappahannock Astronomy Club, which you belong to.
Right. This was back 8 years ago,
Right,
just about.
right. So you've been into photometry and astrometry for a long time. When did you start, by the way?
Well, I started learning about it a while ago because I was always interested in minor planets and asteroids and being able to calculate orbits and learning how to do that. But it's very complex. There's a lot involved with it. And I've got a couple of books. I know Wilman Bell has sells some books that talk about how to orbital mechanics and how to calculate orbits and stuff like that. So I did that back 20 years ago. I started thinking about it more. In high school, I was always interested in that, but then the technology and the capabilities came along for me to really start learning it with these books and other things.
Mm-hmm.
And then back when I was away from astronomy for 15 years from my Meade Schmidt Cassegrain. I was always visual back in the 80s.
Sure.
And then I didn't get back into it in the early 90s, and then I didn't get back into it until 2008.
Oh, wow. So you
And
had a couple of gaps there.
so 2008 is really when I started going out and looking at all the newfangled equipment and how everything had progressed so much with cameras. And early on, I did some DSLR, actually some not DSLR, but film camera images through my Meade Schmidt Cassegrain of the moon. I actually connected a video camera up in the 80s to my Meade Schmidt Cassegrain to do some lunar stuff, but nothing real. I didn't get into it like Scott did with the pain in the ass tracking and all that stuff. I didn't have time for it. I didn't have time to do all that. I knew about it, but I didn't really get into it at that point. Not until 2008 when I went out and looked and see, oh, they've automated a lot of this stuff. It's time to get back into it.
Yeah.
So
Right.
And it's technology that I was really into. So that's when I jumped with both feet back into it in 2008. And that 4-year journey from 2008 to 2012 is when I was almost like working a full-time job learning it. And then I wrote my first book.
Mm-hmm.
So
at this time, this presentation is just coming right off the heels of all of that experience, and
right.
right. So,
And
if
I
someone wanted to get in touch with you later, maybe to give a talk about science for amateur astronomers, they
Right.
just send you an email, or
Yeah, just send me an email, jrh@explorescientific.com.
yeah,
You can put that in the chat, I guess.
I will.
And I've gotten quite a few emails from these shows over the last few months. It's kind of neat to see people and get feedback, personal feedback on the shows, and stuff we're talking about.
Yeah, we have a great audience.
Mm-hmm.
Yeah. Well, great.
So today I haven't had a lot of time to prepare. I'm busy working on a couple of projects that are really on a tough timeline for me. So I keep telling Scott, every time he calls me up in the afternoon, said, "What are we going to present today?" I said, "I don't know. I haven't thought about it."
The truth is that he's got tons of stuff to talk about. So,
yeah. But the nice thing is I've talked about stuff in the past, and I can pull those things out on the fly, on a moment's notice. And so I just said, I remember this one talk I did. I can do this, recycle this talk.
Sure.
And it's just for a beginning audience. So if you're getting into imaging and you're interested in science, these are two of the main tools we use in science to do scientific investigation of the objects that are out in space, that are in the universe: photometry and astrometry. And both of these are really fundamental sciences. The third triad that's big for astronomy is spectroscopy. All right, that's the third one, and spectroscopy is what started astrophysics, to where we could understand what's really going on in the stars and measure and do measurements like that. But the fundamental basis of astronomy is astrometry, which is a measure of the position of objects in the sky, and photometry is the measure of brightness, the brightness of objects, and it's really relative brightness. and objects in the sky. So that's what I'm gonna start on this talk. I'm not gonna spend, this is an hour-long talk. So I'm probably gonna spend 20 minutes maybe, or I've already spent 5 minutes introducing it. So I might spend another 15 minutes going over the first few slides, and then we'll continue on the next show. All right.
Right.
Are there any questions right now?
Not yet. Somebody, Chris Larson does want you to do a seminar on science for amateur astronomers, please. So,
On general science, yeah, I can do that. This is part of that, but I can do a general talk, introduction to science for amateur astronomers. That'd be a good topic for a talk.
sure. Yep, that's where we're at right now.
All right, so we're going to be talking about the history of each of these techniques and how they were developed over the centuries, and how we use these high-tech measurements today as amateurs and as professionals. In general, I can say that amateurs today have all the tools that the professionals have pretty much in these areas. We do just as good a work as professionals do. We're limited, of course, by the size of our telescopes, and that kind of bounds us in terms of the precision we can do. But again, there's a lot of, we're pushing the envelope there also in terms of precision. So that's a general statement I can make. So I'll get past this. All right, photometry. We'll start with photometry, and that's all I'm going to talk about today is photometry. Hipparchus was the first, was a Greek astronomer. He made observations of and created a catalog of stars, 850 stars. And he was the one that came up with the magnitude system that we use today visually. All right, so that's pretty long ago.
Yeah,
And they have, that's
going
pretty,
back.
that's a long time ago. So at that point, they were able to detect visually differences in the star magnitudes, and they actually created a system to do gross measurements of stars and whole magnitudes. And it turns out that he assigned, so basically humans can see stars to about 6th magnitude, which are the dimmest ones we can see visually in general. Some people can see dimmer, some people not quite so dim, but, and then the brightest stars, there's very few of them. Sirius is the, I believe Sirius is the reference star. Now, the magnitude system is a relative measurement. So you basically say, okay, I'm going to assign the brightest star as magnitude 0, or magnitude 1, I should say, okay. Sirius is actually magnitude 0, okay, in the modern time. But Hipparchus basically classified stars from magnitude 1 through 6, with 1 being the brightest. And that happened to be a change of magnitudes of 5 magnitudes is equal to a 1 to 100 magnitude change in linear range. So it's a brightness range of 1 to 100, okay? So 6 magnitude is 1% the brightness of the first magnitude is what that means. It's an exponential scale because your eyesight is exponential. It's a wide dynamic range instrument in terms of your eyeball. So you're able to see that wide range of brightnesses. And in 1856, English astronomer Norman Pogson made the measurements and said, yes, this is what it is. It's a 1 to 100 ratio nominally between magnitude 6 and magnitude 1. So what that is, that's 5 magnitudes, okay? You got a 5 magnitude change, which is equal to a 1 to 100% change. That's a fundamental thing to remember about magnitudes. So since it's a logarithmic ratio or logarithmic function, you know, you can do an equation to calculate what's the difference between each magnitude. All right, I'm not going to go over the math, but this is basically it. 5 magnitude range is equal to the log of 100 times x. Okay, that relationship. And x happens to be, if you want to calculate a magnitude in terms of brightness relationship between 2 stars, you use the value, I'm not going to go over that, but it's basically this right here, minus 2.5 times the log of the brightness ratio between two stars. That's the delta magnitude. Okay, so for example, if you have, well, I'm going to say that. So basically, this is a little confusing to people. I don't want to get into it too much, but that's the equation to calculate the brightness ratio between two stars. What that means, the way the math works out, is that each magnitude is equal to 2.512 times brighter than the next, or dimmer than the next. So the numbers just happen to be close to each other. It's a little confusing because the numbers are close, but you can basically say that each star in each magnitude, when you go from like 2 to 1, it's 2.5 times brighter than the previous magnitude or the lowest magnitude. So that's a general thing. So that's a fundamental thing to remember, is that each magnitude star is 2.5 times dimmer or brighter. Okay. Now, so that's the thing to think about in magnitudes. So photometry, this is a pretty wordy definition, but photometry is a relative measurement of the flux or intensity, brightness of the astronomical object's electromagnetic radiation. That's really a scientific, more of a nerdy type of definition that talks about electromagnetic radiation. And of course, you measure. It's important to understand that, because you measure magnitude, relative magnitude, in certain ranges of electromagnetic spectrum. So you may measure magnitude in the V band or visual band, right? Your eyeballs, that matches your eyeball. This is the magnitude according to your eyeball, but you may get film, which is blue sensitive, that would have a different magnitude value for that object, right?
Right.
So it's important to understand that photometry takes into account the wavelength range that you're measuring. All right, that's the main thing with the photometric system. And there's defined photometric systems where you have filters to do these measurements with a camera. Some people may be familiar with the UBVRI system, developed in the 1970s. And the most common magnitude band that is used by amateurs today is a V band, visual band. And the V band filter was developed to be able to take photographs using a V band filter and compare them directly to naked eye measurements. So like the AA's-VSO has a long, over 100 years of visual estimates for star brightness in their database. But when photography came along, they wanted to be able to compare those, keep the history of those visual measurements and compare them directly to the photographic measurements. And the way they did that is they developed this V-band filter to be able to correlate what you saw visually with what you see in a camera with the V-band filter. So that's the reason that we have it's called a V-band filter, because it's a visual band filter. And that's in this Johnson-Cousins.
So that's the green.
It says green light, right?
I see.
Now, it doesn't match perfectly, of course. It's never going to do that, but it's close enough to really make good correlations to the measurement.
And it's easy to see that you can have in different bandwidths, you can have different magnitudes, So.
That's right, exactly. Because stars are different types, and this is part of the spectroscopy, right? Stars that burn either hotter or higher or lower temperatures put out different magnetic or electromagnetic spectra, and you can tell whether it's and that's what the type system for stars. Oh, be a fine girl, kiss me right now, sweetie. OBFG, all those types are based on mostly on the wavelengths that they radiate in, and so. Photometry in the 20th century was developed by Johnson. He developed the UBV system in 1953, and then it was extended by work that astronomer Alan Couzens performed in the red and the infrared bands, creating the RCIC standard, along with, and if you can guess, the RCIC stands for cousins. He developed those too.
I see.
And so that's why it's called the UBV RCIC standard, or just UBVRI, you'll see it called. In 1992, Arlo Landolt published a list of photometric standard stars measured in each of these band passes. So those are reference stars that have been measured in these filters to be able to calibrate your own existing filter system. So you have a bunch of reference standards. It's just like having in temperature calibration. Okay, we use the boiling point and the freezing point of water, 32 degrees and 212 degrees, as two reference points when you're calibrating a thermometer. Okay, because it's very well defined, it's very precise.
Sure.
When you take, and when we do it with ice at 0 degrees, you basically put crushed ice into water, and it's a transition. The transition point between ice and water is what you want to measure.
I see.
And that's what 0 degrees Fahrenheit is. So that's just like these filters. So these filters, these standard stars now have a reference point for us to measure brightness or relative brightness with these filters, and we can compare it with our measurements with our instrument compared with the standard. We can calibrate our instrument that way. So that's why it's important to understand what these photometric stars are, standard stars are. Are there any questions so far?
Well, in order to do these kinds of measurements, of course, the most accurate ones were done photographically.
Right.
But there must have been, of course, there was a time, since this goes all the way back to Hipparchus, okay, that there were these visual estimates of
Yes.
magnitudes. How did people make a decent visual magnitude estimate?
So what?
Where it was a
Yeah. So
reliable estimate?
right. So what you do, it's like I've been saying, it's a relative measurement. So you have to have reference stars to
Okay.
compare. And what Hipparchus did, I think, I'm going to read up more on it, but what he's established a magnitude 1 star as a reference. Okay.
Okay. Brightest
And
star.
then you step down the chain, right? So then you develop, okay, this is a reference of 1 magnitude. Now, what's a good reference for magnitude 2? And then he compared, and what he did, I think, was that, so he sees the brightest ones and the dimmest ones, right? And then he kind of picked out early on, he noticed that there's a certain ratio of brightness between the brightest and the dimmest.
Right.
And then what he did is he picked out intermediate ones, okay, in between the brightest and the dimmest, and kind of
Maybe
split
you
it up
work
evenly.
something
It's like,
right
how do you
in the
make a
middle,
ruler?
Let's go to the middle again. And the
Right, it's like,
middle.
how do you make a ruler, right? You got the endpoints of the ruler, and then
Yeah.
you divide it in half, and then in quarters, and then in eighths,
Yeah.
And that's how I think that's probably how he did it with the stars. He kind of looked at, okay, what stars are between these two,
Yeah. Exactly.
and said, this is third magnitude or whatever, you know what I mean?
Right. That's still, I mean, having been a photographer and, using film and using light meters, and then being faced where you didn't have light meters at various times, and just having to look at the light and guessing what your
Right.
exposure is going to have to be,
Right.
I had to do that on a number of occasions, and after a while you can get pretty good at it, just by looking at the quality of the light.
Right.
So I'm just, it'd be really interesting to me to see someone really kind of walk through what Hipparchus did to establish that.
Right. That'd be interesting.
course-
That would really be interesting.
That was a giant leap into science back then, so.
Right.
And I understand Hipparchus didn't like the idea of astrology being involved in the astronomy work he was doing, and a bunch of things. So
He was into measurement. And that's the
Yeah,
that's the basis for science, right? Is
Go
measurement and
2,000 years.
observation.
It
Right.
does go back 2,000 years,
Yeah.
So it's pretty amazing that he was thinking that way, and it makes me wonder who was inspiring him. Who did he admire? And because I don't think that he came out of a vacuum. So
No, there had to be a group of people that he was working with and
Mm-hmm.
to pass around these ideas because they're pretty advanced ideas, back
Yes.
then.
Right.
Of course, mathematics was being developed, logic, was being
Sure.
developed, and
And then it just in watching your presentation, it looks like there were these kind of long gaps between. There was, a more refined way of measuring the stars.
right.
And then it starts getting closer and closer, and now here we are, with the Johnson scale or whatever.
Yeah, and then we've even got more precise
scale.
than that. But you can see it from BC all the way to 1856. It wasn't until 1856 that it was formalized as a measurement.
Yeah, that's a long time.
That's a long time,
Very long time. So yes.
so that's kind of interesting. Let's see, where am I at? So I don't know how much longer you want to go, Scott.
Well, we do have to get ready for our global star party, but uh, why don't you just walk us through the rest of this? We don't have to get in super deep, but
Well, I'd like to just continue it the next time if we could,
oh, that could be that way you can give a better.
because this photometry, let's see how far I got. I still got a little bit of ways to go. That's an introduction to the
All right.
photometry. The next time I'm going to do an introduction to astrometry,
Sure.
which is the next thing. So I'll continue next time from starting there.
Sounds good. Okay.
Okay. All right.
Sounds good. Excellent. Before we go, I wanted to talk about a couple other things. One of them has to do something that we're going to try new for this global star party. Is we're going to have something I call the final hour. Okay, in the final hour, we're going to read off the login credentials. So for anybody watching the program, if you guys have something you want to contribute, you want to show in astronomy, it needs to be about astronomy. You have to have a video connection and a audio connection, but we're going to read off the login credentials to our waiting room. Okay. From there, Kent Martz will check your audio and video and make sure you're not trying to sell a ShamWow or something. Okay. And it's going to be about astronomy. And we'll let you in for the final hour of the Global Star Party. And that's for anybody watching anywhere in the world. And we'd be happy to have you on. If you got a big presentation, we can give you 5 or 10 minutes. If it's something shorter, you just want to show what's in your telescope, or you just want to show your latest image, even, which you could do. We'll limit it to like a minute or two. But towards the very, very end, it kind of gets free form, and we let people share their screens and talk to each other and share with the rest of the audience until it kind of dies down, and that's when we wrap up the show. So, but I think that's a great way to get more people involved in the Global Star Party and to let you experience it. And so we'll be doing that for every Global Star Party from here on out. Also, I wanted to talk to you about the February 4th event. This is the 115th anniversary of Clyde Tombaugh's birthday. And Clyde Tombaugh is credited with discovering Pluto, which, there's still the big argument whether or not it's a planet. In my book, it's a planet. Okay, so it's a world anyways. So I know there's people that would argue that point with me, but I kind of side with Alan Stern and David Levy and a bunch of other people that think it's a planet too.
The term world is really a good one.
Yeah, it's a world.
Mm-hmm.
It's a world, and so that it has an atmosphere. It's got geology. It's got there's chemistry going on. So it's and it's got a moon. So there you go. So that will be on the 4th. Now, to help us celebrate this celebration of his birthday, it will be co-hosted by Astronomy Magazine and their group of contributors and editors, including David Eicher, who's going to be on with us tonight. So, we'll talk a little bit more about that that Global Star Party on February 4th. And then on February 8th, starting and for a few days until the 11th, we'll be broadcasting live the Winter Star Party. So that'll be really enjoyable and great, because they're going to have some legacy lectures from guys like Dr. Mike Reynolds and the founder Tippy Dioria, maybe Don Parker. There was some incredible lectures and stuff like that. If you didn't go to Winter Star Party each year, you really missed something. And so I'm looking forward to that too.
That's something I just realized that one of the pioneering things you're doing with these live broadcasts and star parties is you're kind of making a theme star party type of thing, where you have different groups and different, there's always been different star clubs giving star parties, but in terms of specific types of star parties, like you said, the magazine editors or the magazine group,
there's just so much.
It's kind of neat. I mean, you could come up with other kinds of themes, maybe.
Sure. We could come up with a Hubble theme. How about that?
Oh, how about that?
We got Hubble Space Telescope.
Yeah, we got the Hubble's variable. Yeah, Hubble's variable nebula we could look at.
Variable nebula. That's right. That's right. There's a lot of Hubble. So we could probably get some people that worked on Hubble. It'd be cool. So I'll task you with that. Okay.
Coming up with a Hubble themed star party guest list.
I mean, Hubble has redefined astronomy, so and our knowledge of the universe. So I think it's very cool. I think it's very cool that you're related. So, So anyhow,
I take advantage of it every day.
You should.
People remember me only because my name is related to a famous person.
It's not the only reason why, but But anyhow, we hope that you join us tonight. We hope that once I announce for the final hour that you join in with that. I hope that you participate in the questions that the Astronomical League will ask for the prizes that will be given away for Global Star Party. And it's going to be a great night, and hopefully somewhere in the world it's clear so that we can get some live imaging done. So, but if not, it doesn't matter, because we still got so much to discuss and to share. So,
right. Yep.
So anyhow,
and if you have any questions or anything about the training that I'm doing on these shows, just send me an email at jrh@explorescientific.com.
Yeah. All right, thanks, Jerry. And we will see you all soon in 2 hours. So starts at 7 p.m. Central. Take care.
The Southern Cross Astronomical Society of Miami, Florida is proud to present the 2021 Winter Star Party Virtual Edition, February 8th through the 11th. Because of COVID, we will not be able to get together in person this year, but we won't let that stop us from getting together online with old friends and make some new ones. There will be all new presentations about double stars, astroarchaeology, Mars exploration, and more. Enjoy classic videos from past winter star parties by Tippy Dioria, Dr. Mike Reynolds, John Dobson, and more. There will also be door prizes, but you have to register online by January 30th. To register, please visit www.scas.org. Go to the Winter Star Party tab. Select 2021 Virtual Winter Star Party from the drop-down menu. Go to the bottom of the page. Enter your name and email address and press register. And best of all, it's free. Then join us February 8th through the 11th from 7 to 11 p.m. Eastern Standard Time on www.explorescientific.com/Winter Star Party. Mark your calendar. See you there.